Okay, we start with the region bounded by the curves y equals x squared and y equals 8 minus x squared. And if you need a calculator to graph those curves, you need to revisit your pre-calculus. That's all I'll say. You need to know how to graph these by transformations. If you reflect x squared through the x-axis, you get negative x squared. Add 8 to that, you get 8 minus x squared. So you flip it over, you raise it up 8. That's the transformation. You need to be able to graph by transformations. And you need to do that on your tests. You don't want to see calculator output claimed as something you actually did. Okay, there might be exceptions, but for simple, quadratic type functions and exponential functions and trigonometric functions, no, you got to show me how they're constructed. Okay, well, that warning aside, it's clear that these two graphs intersect. How do we find the intersection point? Not by zooming in on a stupid graph on a calculator. That's not how you find intersection points unless you have a very complicated function and don't have any other way to do it. And that's not going to be the case for most problems on the test. Okay? You get the intersection point by setting this function equal to this function in solving. And that's very simple. You get x equals plus or minus 2, and that's a pre-calculus exercise. Okay? So, we know that the smallest value of x that can occur in this region bounded by these two curves, since both curves widen as x increases, was going to occur at the intersection point. So the minimum value of x will be negative 2, the maximum value of x will be 2. So that we can describe this region in a number of ways. One way is saying, okay, x goes from negative 2 to 2, and for every value of x, y goes from x squared up to 8 minus x squared. Because here, y equals x squared. That's kind of obscured by some of the stuff I put in later. But y equals x squared at this point. If this is x coordinate, we come up here and over, we get to y equals x squared. So from x, we go up until y equals x squared. We're not in the region. And then we continue going directly upward, and we stay in the region until y equals 8 minus x squared, after which we're out of the region and we never come back. So we can say that x can be anything from negative 2 to 2, and x squared has to be less than or equal to y, less than or equal to 8 minus x squared. And the set of all points that satisfy this is the set of all points within the region bounded by these two curves. Okay? Now, that's one question. This is how you describe the region in terms of cross-sections parallel to the x-axis. Now that was actually given in the problem, but that's how you would do it. Okay? Now there's another way that we could describe this region, and that's where we let y go from 0 to 8. And for every value of y, we say what the minimum and maximum values of x are. So that I'm looking for something and not seeing it. Maybe I didn't write it down. I'll come back to it. So that for a y value here, your minimum x value is going to be in the curve y equals x squared, and your maximum x value is going to be on the curve y equals x squared. And that's going to be true all the way up to here. Now, this is actually, the intersection is actually at the halfway point. I didn't draw this very accurately. Consider this a schematic. Okay, when we get to the line y equals 4, that's where the two graphs meet. The point negative 2, 4, 2, 4. Okay, above the line y equals 4, our x values will go from this, one point of the y equals 8 minus x squared curve to the other. Different curve. Your x values will be restricted by a different curve when you're above the y equals 4 line. Okay? And that curve is the 8 minus x squared curve. So, what we can say is, for y less than 4, now I say when y is less than 4, x goes from negative y to negative square root of y to square root of y. If y is bigger than 4, x goes from what? Well, y is bigger than 4, y equals 8 minus x squared is the bound. Okay, and maybe I should specify that that's the bound. The bound is on the curve. Actually, I should say bounds are on the curve. Y equals 8 minus x squared, where then x equals plus or minus the square root of 8 minus y. Well, in that case, if I have a y up here, negative square root of 8 minus y is here, and that's going to be that's going to be the x coordinate at which we first encounter the region if we're moving from the left. And then we're going to move along till we encounter the curve again at x equals square root of 8 plus square root of 8 minus y. So if y is greater than 4, x goes from negative square root of 8 minus y to the square root of 8 minus y. That's a description of our region. And we need to break that description into two parts if we're going to use horizontal cross sections. Okay. If we're going to let y go from 0 to 8 and see what the bounds are on x for every y, the bounds are going to depend on whether y is less than 4 or greater than 4. And these are the two inequalities that govern it. Okay. Well, we're going to switch to another question, and then we're going to put the answer to that question together with this description, because you need both of these to describe the region by horizontal cross sections, or this description where the region is defined by vertical cross sections. And I'll explain this red stuff in terms of what we see here.